ಆನ್ ಮಾಡಿ. I think you already went through the video that I sent to the group. If you are not attended in last class, that will be used in for few more students who have not turned up. For them also we are recording the video. Even you can see. We come across with any doubt in that, you can ask me anytime. Okay. As you know, I am doing delivery work.
ಹಾಂ ಸರ್ ಬರುತ್ತೆ ಸರ್.
Delivery work.
ಇಲ್ಲಿ ಬೋರ್ಡ್ ಕಾಣುತ್ತೆ ಸರ್.
ಹಾಂ
ನಡೀತು ಸರ್.
ಇಲ್ಲಿದೆ.
ಹಾಂ ಕಾಣುತ್ತೆ ಸರ್. ಸರ್ ಒಂದು ಟೈಮ್ ನಾನು ಇದ್ದೀನಿ ಸರ್ ನೀವು.
ಹಾಂ ರೈಟ್. ಈ ಥರ ಮಾಡಿ. ಹಾಂ ರೈಟ್.
ನಾನು ಸ್ವಲ್ಪ ನಿಂತಿದ್ದೀನಿ ಕಾಣುತ್ತೆ ಸರ್. ನೀವು ಕರೆಕ್ಟಾಗಿದೆ ಸರ್.
ಈ ಕಡೆ ಬಾ. ಹಾಂ ರೈಟ್. ಈ ಕಡೆ ಬಾ. ಇನ್ನು ಹಾಂ ಓಕೆ. ಹಾಂ ರೈಟ್. As you know, I already told you I am taking molecular physics A. In that we are discussing the rotational spectra of molecules. Last class I introduced the importance of the spectra, why we study spectra, in order to know the energy level and also to know the structure of the molecules. So we also defined the difference between atom and molecule, right? Molecule can independently exist. It is the smallest part which can independently exist. But that condition is not there for atom. It is the smallest part which exhibits all the properties. That is the definition of atom. But for molecule, it is the smallest part which exhibits all the properties, but it should independently exist. And we got unimolecular, uniatom, monoatomic molecules, diatomic molecules, triatomic molecules, like that. And the simplest is a diatomic molecule. Today we discuss the types of the molecules. In that, first we take linear molecules. Linear molecules means the atoms in this molecule are in a line. For example, CO2. CO2 is like this. HCl, N2O. All atoms are in a line. For that reason, it is called linear molecule. What is the difference if you take for such type of molecules? You can expect the molecules are in a line, right? They can rotate this way, or they can rotate this way. They can rotate this way, or they can rotate this way. There are two possibilities. For that reason, we write IB equal to IC is and IA equal to 0. What I represents here is I represents moment of inertia. What is moment of inertia? Inertia for a linear molecule represented by linear molecule. There are two types of motion. One we take linear motion, motion along a straight line. You know all these equations. S is equal to ut plus half a t square, b square minus u square is equal to 2as, right? V is equal to u plus plus AD, and then we got expression for distance covered in nth second. You know, these are equations for a linear motion. Motion is usually complicated. Whenever you start your bicycle, you start from rest, started pedaling, right? You are accelerating, but all of a sudden something comes, you will stop, you are de-accelerating. So it is very complicated. Motion is not that easy. But what we do is, we take all these are written for uniform acceleration. We take acceleration is uniform, right? In any case, it may not be uniform. Velocity, acceleration, it increases, decreases. Whenever you go to your house from your bicycle or vehicle, it is a very complicated motion. You are, if nobody is there, you accelerate. If all of a sudden comes, you de-accelerate, and you stop sometimes. Again, you start. So this is very complicated. But all the time, whenever you want to understand a difficult situation, many a times what we do is we take the simplest. First, try to understand the simplest case. If once you understood this, you can add the variations that can come in that understanding. You can understand the variations that are present. Similarly, first we study all these studies are made for uniform acceleration. But the motion usually is not uniform. The acceleration itself is changing with the time. Right? But to understand, first we go with the simplest. Similarly, every case, for example, to understand the structure of the atom, what we do, Bohr give explanation for hydrogen atom, the simplest that we can think, only one proton in the nucleus, one electron revolving. But if you take uranium, there are 92 protons and 92 electrons. So it is very difficult to understand the structure of uranium atom. But let us begin our study with hydrogen atom, where there is only one. This theory can be extended to hydrogen-like atoms, where we even have Bohr's theory is for hydrogen atom, where we got atom at the nucleus, electron is revolving, right? If you want to extend it to helium, what we will do? Helium has got 2 electrons and 2 protons. But I want to make, I want to apply Bohr's theory to that. For that reason, we take usually the charge at the nucleus as Ze, and we put Z is equal to 1, it is for hydrogen. And for Bohr's theory to implement, there should be 1 electron. So there are 2 electrons in helium. Here Z is equal to 2. But if you able to remove 1 electron from this, then again it is the condition of Bohr's theory. Right? Z it is also Ze, 1 electron is involved. If you want to apply for lithium, there are 2 electrons here, 1 electron here. Here this is 3 plus 3, here the same nucleus. Again I want to apply Bohr's theory. Remove these 2 electrons. Then you can apply Bohr's theory. So this is called singly ionized. 1 electron is removed. Singly ionized helium. 2 electrons are removed in lithium. This is a doubly ionized lithium. They are like hydrogen atom. And for that reason, these are called hydrogen-like atoms. Hydrogen-like atoms means singly ionized helium or doubly ionized lithium. For that you can extend Bohr's theory, and those atoms are called hydrogen-like atoms. Right? Where we got only 1 electron outside. Now, inertia. Usually for a linear motion, what you do, motion in a straight line, we write the expression for force as F is equal to ma. right? M here represents the force that applied. Where is the acceleration? F proportional to A. The acceleration brought in the body is directly proportional to the force applied. And we take mass as constant because we are not approaching the velocity of light. In all these discussion is made for velocity very less than the velocity of light. So non-relativistic case. Don't apply relativity. It is non-relativistic case. In that case, mass is constant. Right? Even this theory is not all the time correct. Newton's theory fails. F is equal to ma is the fundamental equation of mechanics. All motion of a wheel, small wheel in the watch, to the big wheels in the engines or train, locomotives, all governed by this equation, and this is called mother equation of mechanics, and all these equations can be derived from this equation. F is equal to ma is called mother equation, or all equations can be derived from this. So F proportional to A, right? And M we take it as a constant. What M represents here? It is the inertia is proportional to A. Inertia is proportional to mass. If mass is more, inertia means it is the minimum force required to set the body in motion. Now, it is the minimum force required to set the body in linear motion, and that depends on mass. So mass is used to measure inertia, linear inertia, right? When you come to rotational motion, in rotational motion what happens? What is the difference between this motion and this motion? This is called rotational motion. This is linear motion. What is the difference between these two? In linear motion, all the particles on the body are moving, but in rotational motion, a line of atoms, when I hold like this and I am applying the force, this force start moving all the particles except the line of points along this axis, and this is called rotational axis. All particles in this are not moving, other particles are moving, and this is called rotational motion. If a point, if it is very thin, a point we call, or line of points, if it is thick, line of points, if they are at rest during the motion, then that gives a rotational motion. And in order to set the body in a rotational motion, we require certain minimum force, and that force is called moment of inertia. Inertia for linear motion, moment of inertia for rotational motion. You got it? Moment of inertia is same as inertia is the minimum force required to set the body in linear motion, and moment of inertia is the minimum force required to set the body in rotational motion. Okay. Why I am recording the video is in my MSc class we only not dealing with the syllabus. We are giving all this. They are not required for molecular physics. They are coming pass on word like this. But what is there? You should know the fundamental. What is IB equal to IC but not equal to IA in case of linear molecules means here I represents moment of inertia. So what is the difference between a linear motion and rotational motion? Here velocity, distance is measured in meter, right? It is by length covered in a direction, that is displacement. And for rotational motion it is the angle. This described, right? So displacement is measured by theta. Here displacement is measured by s. Here s by t is linear velocity. Here theta by t is angular velocity. So such set of equations we can write for rotational motion also. Right? Instead of distance we get theta, instead of v we get omega, and omega is equal to r theta, r. Right? We write omega is equal to r. That is the relation between rotational motion and linear motion. How you got this? Omega for one rotational motion, the time taken is capital T, and for one rotational motion, what is the angle described? It is 2 pi, so omega is 2 pi by T, right? And what is the linear distance covered if you make it along the length? What is the linear distance for one circular motion? If r is the radius, then L is equal to, or S is equal to, for one rotational motion it is 2 pi r. So V is 2 pi r by capital T. 2 pi by T is nothing but omega. V is equal to r omega. Sorry, where I wrote V is equal to r. V is equal to r. This is the relation. How you can convert a linear motion into angular velocity. So here the role played by M is played by here by the moment of inertia, right? F is equal to ma is for linear motion. Similarly, if I write this equation here, m is equal to I alpha. F is equal to I alpha. Alpha is angular acceleration. A small a is linear acceleration, alpha is angular acceleration. And in case of m, we got I. This is moment of inertia, right? So we have written for a circular body in BSc first sem and second sem. It seems you have written so many expressions for moment of inertia for a circular body. Even you have done that so many experiments in BSc. For linear motion, I is equal to the right mr square. Moment of inertia has mass into radius square, right? And this is I. Moment of inertia can be written in this way. So now you know that moment of inertia is nothing but it is the inertia for rotational motion. Inertia for rotational motion means you have to apply some minimum force to set the body in rotational motion. Okay. What is this IV equal to IC and IA is here? See, for example, this linear molecule, take HCl. On one end H and another end Cl. It is like a dumbbell. Dumbbell, you know. We will do that. Okay. This is of this type. Usually in dumbbell both are of same size. Okay. This is not the. And you have to rotate this. Molecule is like one mass on one side. For example, HCl. H is small and Cl is big. This is a HCl molecule. When you take that as a rigid body. And now I want to differentiate between rigid and non-rigid. What is that rigid and non-rigid? Rigid means during the motion or whenever force is applied on the body, if the distance between the two particles, if it is not changing, right, then it is called rigid body. Right? Now I am applying force on this. If the distance, if the shape of the body is not changing, then that is rigid body. Right? If I put the mud ball and I apply pressure on it, what happens? If I apply force on it, it spreads. That is not a rigid body. This body is not going to change. Right? This is called rigid body. Rigid body, the distance, even though I am applying the force on the body, the distance between any two particles in the body remains the same. It was R earlier, even after applying force is also it is R. Then that is rigid body. But if the body, it was earlier R, but on applying force, if it spreads, it is more than R now. Mu R is more than old R. Here mu R is same as old. Here mu R is more than R. Then that is not rigid body. Okay. That also you should know, because we didn't come across with that.